All right, so today we are going to be talking about complex numbers. This one should be relatively short-ish, I think. Let's find out. So this is chapter 3.3. Should follow along with your book pretty closely, I think. But anyway, to start off, I want to give you guys a problem, or show you guys a problem to work through that pulls up a bit of an issue for us. So this is a pretty simple quadratic equation, x squared plus 4x plus 40 equals 0. And we want to solve this out. I'm going to use completing the square just because that's going to be a little bit easier for this one. So we get x squared plus 4x equals negative 40 to start. Then we're going to add b over 2 squared to both sides. B is 4, divided by 2 is 2, 2 squared is 4. So we'll add 4 to both sides, we get x squared plus 4x plus 4 equals negative 36. Then we factor this out. It's x, whoops. Hold on, can't get an eraser. It's going to be x plus, wow, what just happened? That's the highlighter. Sorry. There we go. X plus 2 squared. X plus 2 times x plus 2 would give us x times x squared, plus 2x plus 2x plus 4, plus 2x plus 2x plus 4x. So that's our breakdown of that one, equals negative 36. Then we take the square root of both sides. We get x plus 2 equals, and then we run into this, the square root of negative 36. Now, I'm sure you know from previous math classes, you can't actually take the square root of a negative number. Nothing times itself is equal to a negative number, right? If I have like negative, in this case, since it's 6, if I do negative 6 times negative 6, that's equal to positive 36. If I have 6 times 6, obviously that's going to be positive as well. So there's no actual way to take the square root of a negative number. And that is what brings us to the number I. There is no real number. Oh, sorry about that. There is no real number that can be squared to produce a negative number. In order to solve radicals of negative numbers, the unreal number I was created. So I is equal to, or I guess I squared is equal to negative 1, or I is equal to the square root of negative 1. So I times I equals negative 1. That's the important thing to remember. So now, using that, we can actually solve these. So in this case, we have negative 36. We want the square root of that. We can think of this as square root of negative 1 times the square root of 36. Remember, these are going to be plus or minus, so we get I over here, I, and then we'll get 6. So we'll have 6I, and it's plus or minus. So that's all we have to do there. This one, we can do the same thing. We get square root of negative 1 times the square root of 121. Square root of 121 is 11. So we have plus or minus 11I. Now this time, we have the square root of negative 6. We can't actually simplify this at all. It's just going to be square root of negative 6. But since we can pull out this square root negative 1 times the square root of 6, this one can't be simplified, but this can be broken down to I. So what we'll do is I square root 6. Now, one of the reasons we write the I on this left side is just because when you have a letter like this, it looks really difficult to tell whether or not it's underneath that exponent. So if I just put like I over here, sometimes people might think that's still underneath your radical, and we don't want people to do that. So it's just this is our answer. Bring that into my circle so I don't have to erase it. So I square root of 6. And then for this next one, so remember when you're simplifying radicals, and I'm not necessarily going to make you guys do this on every problem, but specifically in this section of the chapter, it's probably pretty important to be able to simplify these. Square root of 99. The square root of 99, we can break that down into 9 times 11. This can be broken down into 3 times 3, which is a perfect square, so we can bring the 3 out. So we should get 3I square root 11 for this one. Okay. Next, we're going to talk about complex expressions. So these are basically just expressions that use I or that use solutions with I. So in this case, we would have negative 3 or square root of negative 3 times the square root of negative 3. Now remember that with the square root in a multiplication, you have to use PEMDAS. And yes, I know most people ask why I write the MD and the AS like this. It's because these are on the same one and students often get confused. Doesn't really matter. Point is, exponents come before MD, and a square root symbol is the same thing as to the 1/2. Is equal to square root x. So we have to do these square roots before we can do the multiplication. So when we do this, we would get the square root of -1 times the square root of 3. Square root of -1 is I, square root 3. So we'd do that for both. We'd have I square root 3 times I square root 3. And what this gives us is I squared times the square root of 3 squared. And of course, the square root of 3 squared is 3. I squared is -1. So we'd have -1 times 3 equals -3. This is a lot of different steps to get to the same place you would get to if you just said, that's the same thing as -3 or square root -3 squared, and these cancel. But it's going to be a little bit more important in this next example. This just says that, remember, the radicals are effectively exponents, so you have to solve them first. So it's going to be a little bit more important in this one. So we have square root of -2 times the square root of -8. Remember, that's square root of -1 times square root 2 times the square root of -1 times the square root of 8. Now in this case, you're going to get I here. This is going to stay where it is, square root 2. You're going to get I here. And then this one, we can break this down into 4 times 2. 4 is equal to 2 squared, so we'd have 2 square root 2. And then we can multiply all of these out. We'd have I times square root of 2 times I times 2 square root 2. That gives us I squared times 2 square root 2 squared. So square root 2 times square root 2, that's square root 2 squared. We have the 2, we have our i's. This is equal to -1. Square root of 2 squared is 2. 2 times 2 is 4. So we have -1 times 2. I guess let's do this. Times 2. So we get -4. Is our answer to this. Okay. Hopefully that makes some sense. Now let's look at adding and subtracting complex expressions. So in this case, this probably seems a bit more complicated than it actually is. Because we're not multiplying or anything like that, we're not going to get any I squareds. And I squared is the only thing we can simplify that's equal to -1. We can't simplify I by itself. So in this case, you can effectively treat I the same as you would an X value, and then just simplify this. So in this case, we have -3 plus 4I plus 5 minus I. -3 plus 5, that's 2. Positive 4I minus I, that's plus 3I. That's all you have to do on that one. So super easy. You can do the 4I minus I, and then you'd have the -3 plus 5. Simplify both of those, you get 2 plus 3I. This one is just a tiny bit trickier. Just remember to distribute this to both. So we'd have -7I minus 6 plus 5I. So this is basically -6 minus 2I. And that's all you have to do for that one. So that stuff isn't too complicated. You can just treat I like you would an X, and it's going to work out just fine for adding and subtracting. But when we get to multiplying complex equations, things get a little bit more complicated. So we have to FOIL this expression just like we would doing our quadratics. So first we have -5 times our firsts. We have -5 times 7. That's -35. Then we have our outsides, so -5 times -9I, that's plus 45I, right? 45I. Then we have our insides, so plus 7I, and then we have our lasts, so that's plus I times -9I, that's minus 9I squared. Now we can simplify a little bit. 45I plus 7I is 52I. -9. Here, we'll keep this -35 plus 52I. And then we got -9 times I squared is equal to -1. So we have -9 times -1. That's plus 9. -35 plus 9 is -26 plus 52I. And that should be our answer for that one. Let me just double check really quick, just to make sure I didn't mess anything up. Where is that one? Ah, yeah, okay, we got it. Cool. Sorry about that. Whoops. Okay. So yeah, remember that I squared is equal to -1, but I does not get simplified. I does not get simplified any further. Okay, now dividing complex numbers is a bit more complex. So if we tried to solve this expression, we have 3 plus 2i over 5 minus I. In order to solve this, we need to use what is called a conjugate. And a conjugate is kind of a fancy way of canceling out i's. If you have a complex expression in the form of a plus bi, the conjugate is simply a minus bi. So basically you flipped the symbol. So in this case, the conjugate of the top one, we have 3 plus 2i. The conjugate of the top one is 3 minus 2i. The conjugate of the bottom one, we have 5 minus I, is 5 plus I. You're just switching the symbol of whatever that is, basically. And the reason is when you FOIL that out, it's going to cancel your, what's it called? It's going to cancel out your i's and just leave you with I squareds or whole integers. So to solve a division of complex numbers, we need to multiply the top and bottom of our fraction by the conjugate of the denominator. So in this case, we'd multiply by the conjugate of 5 minus I. So on the next page, let's do that. So we want to multiply each side by the conjugate. We've got 5 plus I over 5 plus I. So when we FOIL the bottom one, we've got 5 minus I times 5 plus I. 5 times 5, that's 25, minus 5i plus 5i, right? Because plus I times 5 minus I times 5. And then we've got minus I times I minus I squared. Minus I squared, that's minus -1, that's plus 1. So we have 26 basically on the bottom. We'll have these will cancel out. This is the same as plus 1. 25 plus 1 equals 26. So we have 26 on the bottom. And then we also need to FOIL our top. So 3 plus 2i times 5 plus I. When we multiply these, we'll get 15. 2i times 5, 15. 2i times 5 is 10i. 3 times I is 3i. Oh, let me move this. And then 2i times I is 2i squared. So when we simplify this out, this is 13i. This is the same as minus 2. So we'd have 15 plus 13i minus 2. That's 13 plus 13i. And that's our numerator. 13 plus 13i. And then we can simplify this. 13 is half of 26. So we would end up with 1/2 plus 1/2 I. And this should be our answer. Okay, so just remember, multiply the top and bottom by the conjugate of the denominator, and then solve like you would normally. And it should always give you an integer on the bottom. If you get an I on the bottom of your fraction, that means you did something wrong with your conjugate or with your FOILing, one of the two. One of the last things we want to talk about today is the powers of I. So if I squared is equal to -1, what is I to the 4th equal? I to the 4th, you can think of as either I squared squared or I squared times I squared. Right, we can look at a different example if we want to prove this. Let's say we have 2 instead of I. 2 squared versus 2 to the 4th. So 2 to the 4th is 2 times 2 times 2 times 2 times 2, 2 times 2 times 2 times 2. So I mean, this is 16. 2 squared is 4, 4 squared is 16. So these are the same thing. In this case, since we're using I, we have I squared is -1 times -1. -1 times -1 is +1. So yeah, since I to the 4th is effectively I squared times I squared, I to the 4th equals -1 times 1, or -1, which is equal to 1. So basically the powers of I can be summed up as followed. There's I to the 1 is just equal to I to the 2 is -1, I to the third is I to the fourth is 1, I to the fifth is I to the sixth is -1. So basically it's a cycle. It's on a 4-part cycle. What you want to do is if you divide the power of I by 4 and then take the remainder, set it equal to 1, 2, 3, or 4, and this will tell you which one it is. So like if I had I to, let's say, the 37th power, I divide 37 by 4. 4 goes into 7 9 times with a remainder of 1. So remainders is back from like what, 5th grade or something like that. I don't remember when you did remainders, but anyway, so your power is effectively the same as I to the 1, which means that this is I. You could do the same with like I to the 326th. So let's see, 4 goes into 326. I don't know why I chose such a terrible number, but it goes into 300 evenly. So then you just have 26. 26 would be 6 remainder 2. So this is the same as I squared, which is equal to -1. And you could check this by plugging it into a calculator probably. Not actually sure if they can handle powers that big, but you could try. And you should have an I button somewhere on there as well. Okay. Solving quadratics with I. So this is the last thing we want to talk about. Remember, this was the equation that I asked you to solve at the beginning of the PowerPoint we talked about. So we'll do it by completing the square once again. Set this equal to x squared plus 4x equals -40. Then we're going to take b over 2 squared and add that to both sides. 4 divided by 2 is 2. 2 squared is 4. X squared plus 4x plus 4 equals -36. Then we have x plus 2 squared equals -36. X plus 2 equals the square root of -36. So we have x equals -2 plus or minus, and then the square root of -36 is 6i. And that is our answer to that. So basically, whenever you have the square root of something, you'll just use I, or the square root of a negative number. You'll just use I and whatever the number is. Okay, that was a little bit quick, but hopefully this will make relative sense to everybody. It's not terribly difficult. It's really just taking the square root of negative numbers and showing you how to do it using this little expression I. I think personally that the most difficult part of this is just conjugates when you're doing division. But obviously we'll have some time in class this week that hopefully you guys can get help if you need it. But that's all for this one, so not as long a lecture as before.